Hello friends. Now today's part 6 chapter 4 is the most important topic. Solution of system of linear equations using inverse of a matrix. We have already completed by substitution method, or in class 10th we have 4-5 methods to solve the linear equation in 2 variables. But here 3 variables and 3 equations. So algebraically we can solve. But here, using inverse of a matrix. So how we solve this one? First we take the coefficients A1, A2, A3, B1, B2, B3, C1, C2, C3. Suppose this matrix is A. If we multiply by X, Y, Z, then only we will get this form. This matrix suppose X, and right hand side D1, D2, D3 is another matrix, constants. Suppose it is B matrix. Our aim is to calculate only X, Y, Z and using inverse. So if we multiply both the side by A inverse, what we are getting? A inverse into AX equals to A inverse B. And in the part 5, what we have learned? A inverse into A is nothing but I. And what is I into X? X. So meaning is, we want to calculate XYZ matrix only by multiplying inverse of the matrix A to the right hand side matrix B. And in the last article, the theorem number 4, A inverse, the meaning of A inverse is adjoint of A divided by determinant A. If this determinant A value is non-zero, then only we will get the answer of A inverse. The meaning is, this value of matrix A must be non-singular. If it is singular, then this answer comes 0 and inverse is not applicable. So the most important point, this determinant A non-zero or non-singular, then only we apply this method, and in this we will get consistent solution and unique solution. Same as in class 10th, unique solution. First part. Suppose second time, sometime we will get determinant A value 0. Then what we will do? And if determinant A equals to 0, then there will be no unique solution because inverse is not possible. In that case, we have to calculate adjoint of A into B equals to. If the final answer is not a null matrix, then what we say, there will be no solution. And the third case, if adjoint of A into B equals to a null matrix, then there will be infinitely many solutions. So these are the 3 cases of consistency. How we check the consistency of the given linear equations? First method, if determinant A is non-zero, we will have unique solution. That means the solution or consistency of the equation fulfilled. Second case, when determinant A value equals to 0, that is, it is a singular matrix, then you have to test adjoint of A into B, and if it comes non-zero, then what we say, there will be no solution. Third case, if adjoint of A into B equals to a null matrix, what we say, infinitely many solutions. So now we test for 1 or 2 questions of the exercise number 6, 4.6. Question number, say 1. Test the consistency of the given equations. Say question number, there are 6 questions to check the consistency. Say 2x minus y, 5, x plus y, same as class 10th, but we have to use matrix method. So the determinant value, what we are getting? 2 plus 1. 2 plus 1. Determinant value of this A matrix equals to 3, which is non-zero. Hence what we say, there will be unique solution. One more question. Say 3, question number 5. This was question number 2. 3x minus y minus 2z equal to 2. 2y minus z minus 1 and 3x minus 5y equals to 3. We want to check the consistency. So, first we start with the corresponding determinant. And 0. First we check the value of its determinant value. So 3 plus 1 minus 2. Check. 0 plus 5, so minus 5. 0 minus 3, so plus 3. Last, 0 minus 6. Answer is minus 15 plus 3 plus 12. 12 and 3, 15 and 15. It means answer is 0. Determinant A value 0. It means the first conclusion will have no unique solution. There will be no unique solution because determinant A value is 0. We can't get the value of A inverse. That's why unique solution is not possible. Now the second step. We have to calculate adjoint of A into B. So now the second step, how to calculate adjoint of this matrix. You know the revision, how to calculate adjoint. First we have to calculate the cofactors. So first we start with the cofactors. So for cofactors, first we have to calculate minus. So start with the minus. 0 minus 5. For this one, 0 plus 3. For this, 0 minus 6. 0 minus 10. 0 plus 6. Minus 15 plus 3. 1 plus 4. Minus 3 and the last 6. These are the minors. What are the 4 important places where you have to change the sign? You know the star points? These are the star points. First, change the sign. Change the sign. This is 12 number, this is 21 number, this is 23 number and this one 32 number. So we have to change the sign. Now these are the cofactors. This is cofactor matrix. Cofactor matrix, when you transpose, what will get? Adjoint. So adjoint is minus 5, minus 3, minus 6, 10, 6, 12 and the last 5, 3, 6. This is adjoint. What is our second test? Adjoint of A into B, and B of this question is 2 minus 1, 3. 2 minus 1 and 3. Adjoint of A into B we want to test. So multiply. One column, it means we have to write only one time. Only one time. Simple multiplication. First number 2. So multiply by 2. Second number minus 1. Multiply by minus 1. Third number 3. Multiply by 3. Get the answer, only one column, that's why all plus. What we are getting? minus 10, minus 10, minus 20, minus 20 and 15, minus 5, minus 6, minus 6, minus 12, minus 12 and 9, minus 3, minus 12, minus 12, minus 24, minus 24 or 18, minus 6. This is not a null matrix. Is not a null matrix. Hence what we say? Second rule. When adjoint of A into B is not a null matrix, it means there will be no solution. So the answer of this question number 5, there will be no solution for this question number 5. Now, how to solve linear equations of two variables? For example, say question number 9. 4x minus 3y equals to 3. 3x minus 5y equal to 7. You know how to solve this question up to class 10th. But here we have to apply only inverse of a matrix method. So first we take the coefficients step by step. Is a matrix, again is a matrix xy, and right hand side B matrix. Is A, x and B, multiplying by A inverse, we are getting A inverse B. This is nothing but Ix, A inverse B, x equals to A inverse into B. So our first aim is to calculate A inverse. So first we start with A inverse. It means we have to write the minors. So minors 4 minus 5 minus 3, 3, 3, minus 3, minus 5, 4. These are the minors. Place 11, 12, change the sign, 21, change the sign. This is the cofactor matrix. Cofactor matrix, if you transpose, so adjoint, this is adjoint matrix. And adjoint matrix divided by the value of the determinant. Value of the determinant is minus 20. See, minus 20 and plus 9. Again, minus 20 and plus 9, minus 11. Determinant A value is minus 11. It means you have to write here minus 11. Is the value of A inverse. Now when you know A inverse, we have to multiply by B. What is B? Second matrix. Now how we multiply? Again division. Minus 1 by 11, multiply. Minus 5, 3, minus 3, 4. One time because only one column. First multiply by 3, then multiply by 7. Only 1. So minus 1 by 11. Now add. Minus 15 and 21. This is minus 15 and plus 21. 6. 28 and 9. 19. Because 28 and 9. 19. So this is nothing but x. What is x? xy. Compare. X equals to minus 6 by 11. Y equals to minus 19 by 11. These are the two solutions. We can solve these type of 2 by 2 linear equations by inverse of a matrix method. So today's homework is exercise 4.6. You have to solve only up to sum number 10. Only sum number 10. So note down the homework from the exercise number 6. You have to solve question 1 to 10. कर लेंगे ना? ओके. अब हम इस चैप्टर के करीब करीब लास्ट पोर्शन पर आने वाले हैं. So maybe the 7th part, maybe the last part for this chapter number 4, determinants. तब तक goodbye.